Hi, welcome to readmeproject.com.
The paper I have requested is assessing the cost effectiveness of fault prediction and accepting testing. Now let's have a look on our abstract. Until now, various techniques for predicting fault-prone models have been proposed and evaluated in terms of their prediction performance. However, their actual contribution to business objectives such as quality improvement and cost reduction has been rarely assessed. This paper proposes using a simulation model of software testing to assess the cost effectiveness of test effort allocation strategies based on fault prediction results. The simulation model estimates the number of discoverable faults with respect to the given test resources. The resource allocation strategy, a set of models to be tested, and the fault prediction results. In a case study applying the fault prediction of a small system to acceptance testing in the telecommunication industry, results from our simulation model shows that the best strategy was to let the test effort to be proportional to the number of expected faults in a module into log of module size. By using this strategy with our best fault prediction model, the test effort could be reduced by 25% while still detecting as many faults as were normally discovered in testing, although the company required about 6% of test effort for metric collection, data cleansing and modeling. In this paper we also propose a clustering algorithm to identify better test results. The proposed clustering algorithm uses Jaccard similarity measures to calculate the distance between the class files. Let's have a look on our data flow diagram. Start the process, input the dataset and load data. Now we need to analyze the dataset. After that we need to extract module dependency information and we need to extract the cluster modules. Then assign test effort and compute test effort. Then we need to predict the faults. Stop the process. Now let's see the demo of our project. First we need to run main.java in access cost package. So first we need to select the project source file. Click the combo box and select OpenJDK. Here we have selected OpenJDK source package. Click select. The OpenJDK source package has been selected. Here in this OpenJDK we have extracted the previous version and current version. Based on these two versions only we can able to navigate our process. Then click next. So first we need to identify the line of codes in each and every class used in the older version and newer version. So the line of codes has been calculated for older version and newer version. It has been calculated for each and every class files. Then click common classes. So we have extracted the common classes for the older version and newer version used. Then we need to identify the new classes used in the newer version. So these are the newer classes which we have used in the new OpenJDK 7 version 7. These classes are not used in version 6. Then click removed classes. It will show the removed classes which has been used in OpenJDK 6 version. So after extracting all these things we need to calculate the method dependencies. So the method dependencies has been calculated for each and every classes which we have used in our dataset. Then click next. So after calculating all these structural dependencies informations, we need to identify the runnable classes used in the each and every versions. The runnable classes has been extracted now. These are the total classes used in the current versions. So after that we need to calculate the Jaccard distance similarity between the runnable classes and total classes. Click calculate Jaccard. So the Jaccard similarity measures has been calculated for each and every classes used in the packages. The Jaccard distance is being calculated between runnable class for each and every runnable classes and its nearest classes. So after calculating the Jaccard distance we need to cluster the classes. Here it will cluster the closure classes for the each and every runnable classes. Based on this only we can able to predict the faults. Then click test effort. First click calculate test effort. The test effort has been calculated for each and every related classes for the runnable classes. After calculating the test effort, we need to identify the fault discover model. The fault discover model has been calculated based on the formula which have been given over here. Hi of Ti equal to alpha into 1 minus exponential of Ba into Ta. Here Ba and Ta goes to the time estimation for the fault discoveries. Then we need to identify parameter estimation. The parameter has been estimated based on the formula given here. Alpha 1 equal to H1 plus R1 into new line of code divided by 1000 plus R2 equal to reused line of codes divided by 1000. Then click performance analysis. Here the performance analysis based on the existing and proposed method which has been used for cost evaluation and acceptance testing. That's all, the process is over.
Thanks for watching clickmyproject.com.